So patterns with addition and subtraction, that's just listing a sequence of addition problems that have a definite pattern to them. So for example, I might start with something like 4 plus 3 is equal to 7. And I'm going to leave the 4 there, but this time I'll add a 2 and I'll get 6. And then 4 plus 1 is equal to 5. Right, so I have 2 patterns going on here, or 3 really. I'm holding the 4 steady, I'm dropping the second number by 1, and I can see what happens to the sum here at the end. 4 plus 0 is equal to 4. And when we do patterns to try and see what happens to something new, we always start with stuff we know and then build to new stuff. So the first part of my pattern starts with known ideas. And then I move that into the unknown, something we're just learning. So we're learning about integers. So here I see the pattern 3, 2, 1, 0, and the kids are getting used to that number line with the negatives, and they're going to, a lot of them go like, yeah, the next one's going to be -1. So the next thing I should have is 4 plus -1. And so that we don't get these symbols confused with each other, generally, if there's another sign after an addition or subtraction, we put it in parentheses to be safe. And if I look at the pattern on the right here, 7, 6, 5, 4, I think we can all safely assume that the next one's going to be 3. And we could use, say, the charged particles or the chips to kind of confirm that. 4 plus -2. 7, 6, 5, 4, 3, 2. 4 plus -3 should be 1, continuing that pattern. 4 plus -4 should be 0. And then some kids should remember this is an important idea here. That's the idea of opposite, which we've talked about before we've done this. 7, 6, 5, 4, 3, 2, 1, 0. But we're not done yet. They keep going. -1 ought to be next. And over here, it ought to be 4 plus -5. And we can talk about why it makes sense that that ought to be the next one. 1, it fits the pattern in these columns here. And 2, we could think about maybe gain and lost. Gain and losses, we gained 4, we lost 5. Ooh, that's a bummer. So we're down 1. 4 plus -6 is -2, and so on. So we can make these patterns and kind of get kids used to that idea. And then they're going to see things. Well, sometimes when we add numbers of opposite sign, we get a positive, but other times we get a negative. Why is that? Okay, and that feels, some of these feel like subtraction. They do, right? And we showed that before. This looks like 4 minus 1 is 3, and 4 minus 2 is 2, and 4 minus 3 is 1, and 4 minus 4 is 0. Right? So there's those relationships, those other patterns that are kind of hiding in there. And then I can move things around. Like we learned that it doesn't matter whether I do 4 plus 3 or 3 plus 4. And same thing down here. If 4 plus -6 is -2, well, that means -6 plus 4 must also be -2. And we could continue a similar kind of pattern. What if we just start playing with -6? -6 plus 3. -6 plus 2. -6 plus 1. -6 plus 0. -6 plus -1. Right? What are these going to be? Is there going to be a pattern here, just like there was before? And math's full of lots of patterns. So let's kind of think about this here. -6 plus 3, right? I'm not adding as much here. So the answer should be less than before. And we can kind of play around with our chips to figure that out. -6 plus 2, I lost 6, I gained 2. That ought to be -4, right? Big loss there. -6 plus 1. -6 plus 0, well, that ought to be -6. That one totally makes sense, right? Add nothing, and that fits this pattern, right? -2, -3, -4, -5, -6. The next one ought to be -7. Think about whether that makes sense. I lost 6 and I lost 1. Oh yeah, that's bad news. I lost 7 altogether. -6 plus -8. sorry, I jumped to the answer there by mistake. -6 plus -2 is -8. Right, so patterns in a couple of different directions. So we can use these patterns to kind of get a whole bunch of examples to look at, and then we can try and make some rules about it. So some things to note here, right? If the numbers are the same sign, that's a pattern that seems to, let's see, 0 is its own thing. Ignore that for a minute. But if the numbers are the same sign, positive and positive gives me a positive with addition there. Over here is the first time I had negatives combined with negatives in a group. And maybe we could add another one in there just for fun. -1, -2, next one should be -3. -7, -8, next one should be -9. Does that seem reasonable? I lose 6 and I lose 3. Or maybe I could use my chips, right? I have a -6. And I combine that with a -3. And so altogether, yeah, that's -9 right there. And so one pattern that we want to extend, so from simple patterns to more general patterns, it looks like if the numbers have the same sign, they keep that sign with addition, right? Same sign in the end. Okay, so that one's pretty straightforward. What about different signs? I guess we should make a note of that. Let's write that down. So we're looking at addition. Let's make this one in red because I highlighted them in red. Addition of integers. One big pattern observation I see here is that if the numbers have the same sign, so if numbers have same sign, then it seems like a pretty straightforward addition. 6 plus 1 is 7, but everything stays negative. So if numbers have the same sign, we just add the numbers and keep the sign. I add 2 negatives, I get a more negative number. 6 plus 1 is 7, -6 plus -1 is -7. Okay, so kind of like the way we did regular addition, but everything stays negative. But there's another thing going on here. So let's take a look at these other cases. And again, 0 is its own thing. If you add 0, nothing happens. We're going to ignore that. And look at these where the numbers are opposite in sign. And over here, ignoring the 0, nothing happens there. What about these where they're opposite in sign? Well, sometimes when they're opposite, the answer is positive, but sometimes it's negative. And we want to try and figure out, well, how do we know which is which? So let's brainstorm on this just a little bit. So the first few I have here, 4 plus -1, that looks a lot like 4 minus 1. That's 4 minus 1 is 3, and 4 minus 2 is 2, and 4 minus 3 is 1, right? 4 minus 4 is 0. And then all of a sudden I get into the 4 minus 5. That's kind of like 5 minus 4, but I get the opposite answer here. Okay. Up here, every one of these turned out to be negative. And the trick to breaking this opposite sign problem, so again, these two groups have opposite signs. Opposite signs. It's like subtraction, but not always exactly like subtraction, because sometimes I get a negative answer over there. And again, the number line is kind of a key for that. Draw a neater number line. Put it right there. And let's scale it. Here's 0, 1, 2, 3, 4, 5, 6. 1, -2, 3, -4, -6. So here's my number line, partially numbered there. And again, sometimes the subtractions are just straightforward. So if they're opposite signs, it's a subtraction sometimes. And other times it's kind of a subtraction, but a little weird. So here I had 4 minus -5. And if I think about those numbers for a moment, 4 is over here, -5 is over there, and 0 is here in the middle. The -5 is further away. And that's kind of the key there. Since the negative is further from 0, the answer is negative, right? Another example from up here, we get 0 in the middle. I have a -6 way over here, and then I have like 4 over here. The negative was further away. I got a negative answer, right? So once we point kids in that direction, then they start to go, oh, right. And over here, if we think about this example, 4 minus 1, here's the 4, here's the -1. The 4 is farther from 0, so the answer got to be positive. So it turns out if they're opposite in sign, it's a subtraction, and then the answer depends on which number was farther from 0. So the rule there, if the numbers are opposite in sign, then what we do is we kind of ignore the signs and subtract the smaller from the larger. So it's kind of a multi-step. So let's say we have a part A, ignore signs for a second, and we subtract the smaller from the larger. Subtract, go. But that isn't always the case, right? So here I can do that. I can ignore the signs and do 4 minus 1. That gives me 3. Cool, I'm done. But up here, ignoring the signs, I would do 6 minus 4. That's 2. How do I tell it to be -2? So that's the second step. Then the difference gets the sign of the number farther from 0. So the difference that we got above gets the sign of the number that was farther from 0. Okay, so I'm just going to test this algorithm out with some bigger numbers. I'm going to do that in the space up here so I can see my rules. So I use these patterns to generate an algorithm. An algorithm is just a series of steps. So this thing I'm calling addition of integers here is really the addition algorithm for addition. So addition algorithm. So somebody says, okay, can you use this set of steps to do something like -73 plus -25? And the answer is yeah. Over here, it says if they have the same sign, just add them and keep the sign. So I'm just going to view that as like 73 plus 25. 5 and 3 is 8. 7 and 2 is 9. So this ought to be -98. I just kind of add them, let the sign hang out. So that was step 1 there. Alternatively, if I had something like 25 plus -73, here they are opposite in sign. So I ignore the signs and subtract the smaller from the larger. Okay, so ignoring the signs for a second, I would do 73 minus 25. And I got borrowed to do that. So let's see, make that a 6, and this a 13. 5 to 13 is 8. 2 to 6 is 4. So I get 48 from the first step, and then the second step says the answer, the difference, gets the sign of the number that was farther from 0. What's farther from 0, 25 or -73? Yeah, -73. So the answer must be -48. And this set of steps right here, that is the addition algorithm for integers. What's the subtraction algorithm? subtraction algorithm is kind of easier, and it kind of involves this. So let's just do that and be done for the moment. Subtraction algorithm for integers is to rewrite subtraction as addition. How do we do that? As addition by adding the opposite. That's step one. Step two is follow the addition rules. So for example, if I had something like negative 57 minus negative 35, then I would rewrite this as adding the opposite. So that would be negative 57 plus the opposite of negative 35, which is just 35. And then I go back to the other page and say, okay, what does this one say to do? Oh, this one says to drop the sign, subtract, and then the answer gets the sign of the number that was farther from 0. Okay, let's try that. So here I would say, all right, let's ignore the signs for a minute and just write that as 57, take away 35. 5 to 7 is 2, 3 to 5 is 2. So this answer has something to do with 22, but 57, negative 57 is further from 0 than 35, so that should be a negative 22 there. So that should be the result of the answer. So that's the set of rules. We have the addition rule, and then for subtraction, we just rewrite the subtraction as adding the opposite of the next number, follow the other rules. Now, there is another way to think about this, kind of an alternative algorithm. So here I have a loss of 57, and then someone takes away $35 of that loss. So that means I should be doing better, right? I had a debt in my bank account of 57, and they removed $35 of that debt. That leaves me with only a debt of 22. Okay, so I kind of can think about it intuitively with money, with the idea of gain and loss. That's kind of a nice thing to do. But we have these algorithms. And again, the algorithm, right? I didn't draw any pictures. There's no number line here. I've got no charged particles. I got no chips. I just have a set of rules to follow to get an answer. That's an algorithm.